Hello and welcome. In this lab we will be performing a direct shear test on silica sand to determine the friction angle and cohesion intercept. This test covers standards ASTM D3080 and AASHTO T236. We will need the following items to perform this test: a direct shear device, compaction tool, balance, porous stone, and a vacuum. The first thing we need to do is set up the direct shear machine. To do this, we will place a porous stone in the bottom of the chamber, then place our bottom and top portions of our shear mold into the chamber. Make sure that the two pieces line up. We would have initialized the machine to return it to its start point so that the top and bottom of the mold line up. If they don't, we will need to move the shear screw so that they do. Once we are lined up, insert the alignment screws. We are ready to put in our sand. We will be using a silica sand for this test. We will put the sand in a bowl and get a weight, then pour it into our testing setup. Then we will use the hand compactor to compact the material so it is no longer loose. The density doesn't matter as long as we are consistent for all three samples. Enough room will be left at the top of our setup to place our porous stone so that it is flush with the top of the setup. Then reweigh our sand and bowl to get the amount of material we placed into our setup. This will be the same weight we will use for all three tests so that our densities are the same. Once the sand and porous stone are in place, we will move the vertical loading arm into place and put the digital displacement gauge in position. This will allow us to apply a vertical or normal load to our sample. We will use three different confining loads for our tests: 3,000, 5,000, and 7,000 PSF. We will be using a 2.875 inch diameter mold for our test, so we will apply a 130, 220, and a 310 pound load respectively for the three tests you will be running. Once the vertical or normal load is applied, we will remove the alignment pins between the top and bottom portions of our shear mold. Then we will screw down the separation screws to separate the top and the bottom portion of the mold to get rid of any friction that may occur. Once this is done, we are ready to run our test. We will be recording the horizontal load and displacement as well as vertical displacement. The vertical displacement may have positive or negative values, which will represent contraction or dilation. The horizontal displacement will remain constant. We will be taking readings every 0.01 inches of horizontal displacement until we reach the maximum shear load. And then we will take two readings after the loads start to drop off, or until we reach 0.25 inches of total displacement, whichever comes first. We will be running our test at 0.02 inches per minute, so we will be taking a reading every 30 seconds. At the 0.01 horizontal displacement intervals, we will record both the horizontal load and the vertical displacement. Once we have taken all of the readings we need, the test will be finished. We will clean out the sand and reset or reinitialize our setup to its beginning position, replace the alignment pins, and set up our next test sample. We will run this test 2 more times at different vertical or normal loads. That concludes this lab. For additional information, please refer to your student lab manual and get help from your TAs and instructor.